Okay, we want to find if this series converges or diverges. With this one, you can use a comparison. It's quite a tricky comparison. But if you know something about cosine, then you could do it. So we know that, first of all, what is cosine? We have a circle, and then we have 1, 0, and -1, 0. Right? And we're always doing integers here. So in any case, the only way in which we could get 1, because remember, cosine is this, and this, and this. It's always this side of the two terms. So we have a bunch of terms, and cosine is always this one, right? And we have a series. So in a series, we're plugging in integers. So we would need a cosine pi of n. We would need a cosine pi of n in order for this to ever reach here into -1 and into 1, right? So this could never, ever equal 1 if we don't have pi. Then we just have cosine of n, and then it's going to be a bunch of values, but we know for a fact that the values are never going to be 1. Okay, so that's the first thing that we have to know. Because we're plugging in integers, and there's no pi right next to that n, it can never be 1. Cosine's never going to be 1. That means that this numerator here must be less than 2. That must be less than 2, and that's going to give us a hint into what series we can compare this to. We can compare this to a very similar series, which is nonetheless just slightly different, and we're doing a comparison to see which one's larger, which one's greater. If one converges and this one's smaller than something which converges, then we can say that this also converges. If that series is larger, and if the series diverges and this one is larger, then this also diverges. So we have a very similar series here, which is 2 in the numerator. Why 2? Because here we have 1, and we know that this number here is always going to be less than 1. It's always going to be less than 1 because no matter what we plug in, the x value of that cosine is always going to be less than 1. It can't actually be 1 because it has no pi. And 1 is the largest it could be. It's the largest it could be ever. Because remember, with cosine, you have this thing which goes from -1 to 1. From -1 to 1. So, given that, now we know that this is less than that. Because this is always going to be some number less than 1. You add 1 to that, it's going to be less than having a 2. So I totally see how this is kind of tricky to think about and perhaps just remember if you see this on a test. So now it's easy. Now it's easy because this is a geometric series. This is a geometric series in which we're taking something to a power. So we have 1 over e, and we're taking this to that power. So that's a geometric series, and we know that if we have something smaller than 1 with a geometric series for our common ratio, since this is smaller than 1, then this is going to converge. This is going to converge. And if this is smaller than something which converges, this is also going to converge. So this converges by an admittedly tricky comparison.